My name is Christian Vogt. I'm a scientist. I'm working here at the University of Bremen for the Primus project, which is about generating ultra-cold atoms in the drop tower. In Primus, we want to measure forces, and if you want to measure a force, you need a test particle that you put into the force field and then see how it moves in there. So we want to use atoms as these test particles. And on ground we get two problems, which is the first one is that the atom just drops due to gravity to the bottom of your vacuum chamber and it's lost and you can't use it anymore. So we're going to the drop tower, so we're having longer free-fall times. And the second problem is the temperature, because the atoms are moving and they're flying around, and then you can't use them anymore as well. So what we want to do is we want to reduce the energy, we want to reduce the velocity, and that means cooling. And this is what we're doing in the drop tower. So in the Primus drop capsule, we're cooling the atoms in two steps. The first one is called laser cooling, where we have the atoms moving one direction and then shooting with the laser from the opposite direction and then transferring momentum to the atom, so it slows down. And at a certain point, the momentum is too large to cool the atoms any further, so we need a second step, and that is called evaporative cooling. So we're having an optical potential, so we're shining a laser light in there, which forms a potential, which is like a bowl, you can imagine it, with a lot of marbles moving around in there. And then you have hotter atoms and colder atoms, and the hotter atoms are moving further up the hill than the colder atoms are. So if we're shallowing the potential, then the hotter atoms are allowed to escape from the trap, and therefore we're having a bunch of cold atoms that we can use for the experiments. The results of these experiments will lead us to two different directions. We are measuring tiny forces, so this is nice for fundamental physics. But if we want to do so, we have to move to space, actually, because we need a higher repetition rate of the experiments and we need longer free-fall times. But if you want to move to space with something, you have to show that it works in microgravity, the techniques you're using. And this is what we're doing in the drop tower as one step. The other direction is that we're shrinking these experiments, or these sensors, because these are actually lab-sized, or they were, and now we're shrinking down to the drop capsule already. So we're very close to having mobile devices that we could carry around with ourselves. The most interesting application from my point of view is using these to measure gravity, because we're not talking about the gravity of the Earth, something like this size, but we're talking about the gravity of a human body or a car that passes by. So these are very precise measurement devices. So right now we're using the drop tower, which is a great facility, but it has a limited repetition rate. In our case, there are just 2 drops per day at max. So we're actually hoping for the GTB Pro, because we have a higher repetition rate and then we can do a lot more measurements in a single day.